Centrifuge at a high speed. So we want to do 15,000 times G.
What in the hell?
Say 10. We'll try 10. 10,000 times G at 10 degrees C. So we're going to go find out what makes 10,000 times G. We'll switch that in our procedure. What makes 10,000 times G with this rotor? So we'll bring our samples over. First, make dang sure that we're relatively balanced. Bloody heck, we're not.
Jeez, I'm an idiot.
So, that's because I spilled part of my sample, I bet. Like a doofus poofus. Okay, and like I said, you will have some of your buffer waiting. Good. Okay. Tighten this plank down again. Cross thread it, but it is kind of acting weird. Okay, so now let's go find out from our table what's 10,000 times G. Turn this back on again. I dutifully turned it off. So we look at our thing and we want maximum relative centrifugal force. Come down here till it says close to 10,000. There's 10 grand right there. So it says about 8,000 RPM for this rotor. So everything is fine. Our temperature is good. Don't have to worry about that. But what we do want to do is change our RPM to, we said 8,000 it was? There's 8,000. Okay, so I think we're ready. What's our time again though? I don't remember what our time was. Let's see. 10,000 times G for 10 minutes, okay? So, we have to change our time to time, dummy, 10 minutes. And we're ready, okay? So again, put our pieces in. Make sure there's no ice on them when you put them in. Opposite sides. We'll go down to the bottom, grab this, stick it down, lift up this top piece, grab the bigger piece with your fingers, hold the rotor and turn it to the right. There. And then the little piece is loose. The top, this one's good. The little piece is loose. So you turn it again, this time to the left. Did it correctly this time. And there she's nice and solid. Okay, this top is not loose. So we're ready to roll.
Thank you for pressing the self-destruct button. This ship will self-destruct in 3 minutes.
We're good. Take one last scan like a pilot. Make sure everything, all your instruments are right. Hit start. And then hang out. Again, waiting for this thing to get to 8,000. Just to be sure. And then this baby will run for 10 minutes. And then what we're left with is a pellet that we think is a pellet of bacteria. And we'll go down to the into my other lab down there, and we will show you how to resuspend that in 5 mils of buffer. Okay, so I pulled them out of the centrifuge, put them on ice, and I don't know if you can see this too well, but that's my pellet. Okay, not terribly exciting. But that should have now in there bacteria, because this is after the high-speed spin. And this liquid, the supernatant, we just want to get rid of. Okay, so I am just going to decant this very carefully into a container. You could use the sink. Okay, I'm just going to decant it into here because it's easier on the camera. But you just very carefully turn this over. Now that pellet is pretty tight. At 10,000 times G, not much should come out of there. But you let all that go. That's all can be tossed, because this is not what we want. Our bacteria are in this pellet down here.
Holy shnikes.
Resuspend this pellet in 5 mils of 5 mils of buffer. In this case, we're just going to use the plain old phosphate buffer that's going to be supplied to you. Okay? So you take, we're going to have 5 or 10 mil pipettes. It depends on what we have in the lab. This happens to be a 10 mil. And to resuspend the pellet, you take a pipette aid and you take a little phosphate buffer and you suck up your 5 mils. And you take the this guy, and we know where our pellet is. Our pellet is down there. And so we're going to take this and we're going to repeatedly shoot out and suck it up. Shoot it out, suck it up. Shoot it out, suck it up. Notice I'm trying to basically wash the pellet and I'm dissolving it as I go. So that pellet, that's bacteria that's on the inside bottom, is being kind of dissolved in this buffer. And you do that a few times until you're satisfied that you have resuspended the pellet, which I'm pretty satisfied.
Yeah, baby!
So now, you now have, in this case, the sodium one, but you now have all that cloudy stuff in there, we hope, is chock full of bacterial goodness. So this is your starting point for doing your dilution series, which is in another video. Okay? So when you dilute this out, you're going to get numbers for CFUs, and you're going to compare it to what you get when you just use plain old phosphate buffer. Okay? So that's the setup for the lab, and that's basically the procedure that you're going to do for isolating bacteria from soil. And remember, it's a real experiment. We don't know which one is going to be different or if they're going to be different at all.
Dang!
So it's a real experiment, not hard to do, but it gives you some good practice in doing good lab of hands stuff and thinking through the procedure, what you're going to do. Okay? All right, let's get to it.